everybody, and welcome to our live stream from here at the California Academy of Sciences. My name is Mary, and I'm going to be your presenter today. And normally we've been doing this show in our planetarium, that direction for me, but we're doing some work on our planetarium right now, so we're switching things up a little bit, and we're giving you our live stream from a different part of the building, but still with the same software that we use in the dome called OpenSpace. So today I'm going to be taking us on a tour of the universe, and we're going to get a close-up look at a couple of planets. And something really fun about this format here is we can be a little bit more interactive if we want. So if you have a question or if you have a place you would like to visit, feel free to drop that in the comment box, and my producer Bing will help me out by looking through and seeing if we have some interesting questions or places that people would like to go. So feel free to do that throughout the show. But I'm going to switch us over to looking at our planetarium software here, OpenSpace, and that's what we're going to be flying around in. And something really cool about OpenSpace that we use for all of our 4:30 p.m. shows in the planetarium and for some of the live streams that we do here is that it is free open source software, so you can download it at home. And it's really cool, all based on real data and real images and such of the places that we visit. And I don't know how good y'all are at geography, but you may have been paying attention to what we've been flying over here. Looks like we're going over Italy currently, so that's neat. And something really cool as well about this being open source based on real data is that this is where the International Space Station is right now. So we were just floating above the International Space Station. We're pulling away from it slowly, and I'll bring up a line so we can see where it is. So that yellow line that I just brought up is where the International Space Station goes around our planet. And as we zoom away, I do like to mention, I always like to start out my tours out here in the universe at the International Space Station because it gives us a little bit of perspective on how far we're going to go today. So we'll see how far we get because we do have a few places in the solar system I would like to stop along the way, but we might make it as far out as the edge of what we can see in our universe. Ooh, any black holes we can visit? That is a wonderful question. I don't know of any black hole locations off the top of my head that I have loaded up in this software right now. So probably not going to visit any black holes today. But if I remember, and Bing can maybe bring that question up again in a little bit when we get out to our galaxy, I'll show you where a black hole is, a supermassive black hole. So I'll keep that in mind for later. Thank you. But yeah, so we are looking here at the International Space Station where it goes around our planet. And this is as far as humans are traveling out into space right now. So up to the International Space Station, which is actually pretty close. It's only a few hundred miles above the Earth's surface. But that's how far us human beings are flying out into space currently. But we'll see how far we've gone in the past, and we'll also see how far anything we've sent out into space has gone so far. But right now, we've got a few astronauts up on the International Space Station, and people have been living up there for about 20 years now. But throughout the show, I'm not going to spend a ton of time at any one particular spot just because I want to visit a lot of different locations. I want to take us to a couple planets at least, maybe see if we have time to zoom really, really far out in the universe. So we'll only stop a few places along the way. But our next stop as we go out into our universe is our closest natural neighbor in space. So I want to emphasize natural neighbor because the International Space Station is a human-made satellite that we have going around our planet. And we have several human-made satellites going around the Earth, tons and tons of them. But the moon is our closest natural satellite. So this is not a human-made object, but instead a natural object that is going around us that has been here for a very, very long time. And looks like we've flown over to the dark side of the moon, which, despite what you may think from some popular music and whatnot, there is no permanent dark side of the moon, though people often think that. And it makes sense that you might think that there is a permanent dark side of the moon. But the dark side of the moon changes as the moon goes around us. But there is a permanent far side of the moon. And if I rotate us around a bit, I can show you where the far side of the moon is. So right over here, this is the side of the moon that is always facing away from Earth. I'm going to see if I can spot Earth in the background. Let's see if we can find it. Having trouble seeing it, but trust me, this is the side of the moon that we never get to see from here on Earth. But the side that we do get to see is this one over here with all the different lovely dark areas, which we call Maria. And I'm going to zoom us in pretty close to the moon so you can take a look at some of its lovely features with these lovely high resolution images that we have of it in OpenSpace. And I always stop at the moon as well, in addition to always stopping at the International Space Station on these tours, because again, it's going to give us a little bit of perspective on the incredible distances that we are going to travel today. So I mentioned that this is our closest natural neighbor in space, right? But still, it's about 250,000 miles away from us. So really, really far away already. And as we go out today, we're going to see distances of millions and billions, sometimes trillions of miles or kilometers. And so if I keep using terms like miles or kilometers as I talk about how far we've gone, it's not going to make a whole lot of sense, at least not to me, perhaps not for you as well. So I'm going to use this location of the moon to introduce an idea that I'm going to use for the rest of the show. And that is the idea of traveling at the speed of light. So if you can imagine the fastest speed we know of in the entire universe, the speed of light, we don't know of any speed that is faster than it. Imagine going that fast. If we were going that fast, it would have taken us about 1.5 seconds to get to the moon from Earth. So another way we can think of that is with distance. So we can say that the moon is 1.5 light seconds from us, because that's how long it would take for light to travel here at that fastest speed we know. Just 1.5 seconds, pretty quick, about the same amount of time that it took us to get here in OpenSpace. And I did want to make a side note that I did notice some folks in the chat are sharing where they're watching from. So thank you for doing that. Super fun. We've got some people from various states. We've got some people from the United Kingdom. Super cool. And as we zoom away from the moon, this is also the farthest that humans have traveled out into space so far. So all of us are from those different locations that y'all are sharing in the chat of places here on Earth. We have traveled out into space a little bit, out here to our closest neighbor, the moon. But that's so as far as we've gone so far. Humans haven't traveled super, super far into space when it comes to how far apart things are. But we have sent some spacecraft to different places in our solar system, and perhaps even a little bit outside of our solar system too, which we'll get to in just a little bit. But before we visit some of the other places in our solar system, I do want to give us just one more piece to kind of wrap our heads around where we are and how far we're going to go. So I'm going to focus for just a minute on the very center of our solar system, the sun. Now, if we were traveling at the speed of light, again, that fastest speed we know of, it would take us about 8.5 minutes to go from the Earth to the sun if we were traveling at the speed of light. And there's a couple of ways that I like to think about that. For one way I like to think about it is that if the sun just disappeared for some reason, we wouldn't know about it for 8.5 minutes. But don't worry, there's no reason why the sun would just disappear. We don't have to worry about that too much. But another way I like to think about it is that if you walk outside, if it's daytime and you look at the sun, well, first of all, please don't do that. Never, ever look at the sun. It's really, really bad for your eyes. So never do that. But if you were to look at the sun, that's how the sun looked 8 minutes ago, not how it looks right now. Or the moon. That's how the moon looked 1.5 seconds ago, not how it looks right now. And within these few light minutes of distance, these lines you're seeing here in blue are orbits of the planets in our solar system, so where they go around the sun. And as we rotate around, we're seeing the orbits of the smaller rocky planets in our solar system. So we've got Mercury, Venus, Earth, and Mars. And off in the distance, those four we're seeing over there, those are the orbits of Jupiter, Saturn, Uranus, and Neptune. And feel free to suggest places to go as well. But I do have a couple of places that I definitely want to make sure to go that I was planning to head to. Oh, sweet. And then we'll go to Pluto after that. Thank you, Lori. But first, we're going to visit a couple of the giant planets in our solar system, Jupiter and Saturn. And I was thinking that I wanted to go to Jupiter and Saturn today specifically because I've been noticing lately that you can see them really, really easily in the sky right now. So if you take a look at the sky, if it's a nice clear night, and you see, let me turn off our orbit lines here real quick, get them out of the way. There we go. As we fly into Jupiter. If you look at the sun or the sky, pretty soon after sunset right now, you may have been noticing a couple really bright objects in the sky pretty soon after sunset. And those are our two biggest planets in our solar system, Jupiter and Saturn. So if you go and look for them in the sky, they're going to look like really bright stars that maybe don't twinkle, especially if they're higher up in the sky as well. Planets don't tend to twinkle like the stars do. But I thought it would be fun, since in this show we can fly around in space with OpenSpace and we visit those two planets up close. So you can see them in the sky tonight, looking very bright and beautiful, and you can also see them on our screens right now, up close and in detail. And these two, Jupiter and Saturn, are a couple of the easiest to see planets in our sky because they're just so gigantic. Jupiter, for example, if you were able to somehow shove a bunch of Earths inside of Jupiter, I'm not sure how you would do that, but if you were able to do that somehow, you could fit about 100 Earths inside of it. It is a very, very large place. Or 1,000. Did I get that number wrong? I can let Bing correct me in the chat if I totally just had a brain fog and said the wrong number. But suffice it to say, you can fit a lot of Earths inside of Jupiter if you were able to squish them in there. But I do know that it would take, thank you, 1,000. I was off by an order of magnitude. Thank you, Bing. But yeah, I do know you can fit about 10 or 11 or so Earths if you were to line them up next to Jupiter. That's about how wide it is. So that does give you, and I see someone asking about the storm on Jupiter, which is wonderful timing. I was just about to talk about that. So I'm going to flip us around a little bit here because I am noticing that big storm that I'm guessing is the one you're talking about, the Great Red Spot, which we're seeing right over here. Also, the Great Red Spot is near some other storms, my favorite set of storms on Jupiter, what I like to call Jovie McJove face over here, set of a couple of white storms and a kind of long storm sort of over here that makes kind of a grumpy face on Jupiter. And the question was, will that storm ever go away? Because if you know much about this Great Red Spot right here, this is a storm kind of similar to a hurricane like we have here on Earth, but one that is like hurricanes times 1,000. Everything on Jupiter, if there's anything similar to the Earth, it's like the Earth, but magnified by a whole lot. So this right here, you could fit at least an entire Earth in that spot alone. So this is a gigantic storm to begin with. But if you've heard news about the Great Red Spot lately, it is shrinking. It's been shrinking pretty substantially over the last several years. I remember reading about it 20-ish years ago, and it was, I think, 3 or 4 times the size of the Earth, and it's shrunk, and it's quite a bit smaller now. It's about 1.5, I think, at this point. So it is shrinking, and it is possible that it will disappear, or maybe it'll morph or change in some way. So we're still studying it to try to predict and see what's going to happen with it over time. Because these storms, and if you're familiar with meteorology here on Earth, it's a really complicated science. So it takes a lot of work and a lot of predicting to try to figure out what's going to happen with these storms over time. It's very, very complicated. But the Great Red Spot is the biggest one that we know of, and we can see a lot of other little storms. If you see any of these little circles as you look around Jupiter, those are storms as well. And I don't want to stay here too long because I do want to make sure we visit the other giant planet in our solar system that you can also see in the sky right now. So Jupiter is very, very, very bright in the sky. The next planet we're going to go to, Saturn, is also pretty bright compared to especially a lot of the stars that we see, but it's quite a bit more dim than Jupiter. But that's not because it's way, way smaller. It's because it's a lot farther away. So the farther away something is out in space, it's going to look dimmer in the sky. And Jupiter and Saturn, they're both what we refer to as gas giants. So the reason we were seeing those storms on Jupiter is because all the outer layer of Jupiter is mostly hydrogen and helium gas that is swirling around. And I think I see a question about the rings. How many rings? That is a wonderful question. I did learn a little bit about the different rings on Saturn a few years ago when I did a show about the Cassini mission, which ended a few years ago, which took many, many beautiful pictures of Saturn for us. If you have a chance, you should definitely look up pictures from Cassini. It's gorgeous. I'm sure a lot of this that we're seeing right now in OpenSpace is based on Cassini. But It depends on, I guess, kind of how you think of it, because there's different sections of the rings. People talk about like the A ring, the B ring, the G ring, things like that. So you can think of them as different sections. You can think of them as these really teeny tiny rings. So depending on how you feel like grouping them, that might change how many rings there are. But they're not one big solid thing, even though it kind of looks like it from this far out. These rings are made of a bunch of icy particles mostly, and some of it's kind of like snow, sort of. And they do kind of blend together to look like one big solid thing from really far away. But it is a bunch of tiny particles that are all going around Saturn together, some of which are tiny compared to Saturn, but can be as big as like a couple-story house or something like that. So they can get pretty large. But compared to Saturn, they're very, very thin. I can show you how they almost disappear as we go on the side here. And while you can see Saturn pretty decently, just naked eye by looking up at the sky, also, if you ever have a chance to look at Saturn through a telescope, it is absolutely gorgeous. I've had people look at Saturn through a telescope and think that it looks like a sticker because it's just so clear and so bright. And a big reason for that is the rings. These rings reflect a lot of light, so it makes it pretty bright as the light from the sun bounces off of it. And I'll check in real quick. I didn't look this up specifically, so maybe Bing can drop this in the chat for us. But in terms of thinking about the speed of light, I want to make sure we're not losing that idea as we get farther out into space. But to get to Jupiter and Saturn, we've already gone quite a big distance. So to get to the sun from the Earth would have taken us just a few minutes, just about 8.5 minutes. Out here, if I'm not mistaken, we're at a few hours of light distance. So it would take us a few hours to get to either Jupiter or Saturn, way out here in the solar system. And somebody did mention, how thick are the rings? So if I'm remembering right, at the thickest, they're about the size of like a couple-story house or something like that. So not super thick, but they are very, very wide. But let me bring up our planet orbits again. So we can just figure out where we are. So we were just at, let's see, let me orient myself here. So we got our inner rocky planets over here, with the farthest one being Mars. Then we've got Jupiter, and then Saturn is where we just were. And over here we have Uranus and Neptune. And I know that somebody wanted to go to Pluto. And I always love going to Pluto, so let's do it. So I'm going to bring up the orbit of Pluto, which I didn't have up before because I don't usually start out with the dwarf planets orbits being up. And real quick, before we fly in close to Pluto, let me talk just a teeny tiny bit about why it is in that separate category. Until 2006, we called Pluto a planet, just like the other 8 planets that we're seeing over there. But in the late 90s and early 2000s, astronomers started to find a lot of objects out there by Pluto. Objects that we call trans-Neptunian objects, which means that they orbit mostly outside of the orbit of Neptune. Now, if we take a look at where these trans-Neptunian objects are, you can see a lot of them have these really wild, weird orbits. They may go really close into the sun and then farther out. But if you look at them as a whole, you can see that they do kind of make this ring in the outer part of the solar system. So if I toggle that on and off, and if you see this light blue line here, that's the orbit of Pluto, you can kind of get an idea that they're pretty much lining up with where Pluto is in the solar system. So Pluto is what we now call the Kuiper Belt, which is a group of a bunch of those objects, mostly icy objects, mostly really small objects, but a few of which are around the size of Pluto. So as astronomers discovered this, and we're finding more and more and mapping more and more of these smaller objects out there, they started to have a question come up of, well, a few of these around the size of Pluto, do we want to add on some more planets, or do we need to adjust what we call a planet? And it's still something that people talk about to this day and kind of debate, okay, what exactly is a planet? What isn't a planet? But back in 2006, a group of astronomers called the International Astronomical Union got together and they put it up for a vote. They said, okay, should Pluto stay a planet, or should Pluto have a different category? And during that process, they decided that a planet needs to have 3 things. It needs to orbit the sun, It needs to be large enough that its own gravity has pulled it into a round sphere shape, and it needs to have cleared out its path, has to have a relatively cleared out orbit. Pluto did not fulfill the third requirement because it was out in the Kuiper Belt. So it was changed from being called a planet to the new category of dwarf planet in 2006. But even so, I do not think of this as a demotion at all. I think of it as just kind of rethinking and reconfiguring how we talk about things in the solar system. And Pluto is still a very, very interesting place and one of my favorite places in the solar system for sure. And I'm going to, oh, why does it not have a back? Oh, very good question, Christian. So let me turn off the nighttime side of Pluto. There we go. So we're looking right now at what is currently, or I turned off the night side of Pluto so we can see the whole thing. And Christian was asking why it doesn't have a backside, which is a very wonderful question. You come back here, it's all black. What's going on? Well, that's another piece of OpenSpace using real actual pictures and data. So it's actually really cool that it doesn't have anything over here, because what we're seeing on this side is a real image. This is an actual picture of the surface of Pluto. And we got this really high resolution images of Pluto's surface because of a spacecraft that we sent out here. The New Horizons spacecraft flew by Pluto back in, I'm always forgetting my dates today. I believe it was 2015, if I'm not mistaken. It flew by Pluto very close, and New Horizons took a bunch of pictures of the surface of Pluto and sent them back here to Earth. And it is so gorgeous. And we didn't know what Pluto was going to look like because it is so far away that all the images we had so far were really fuzzy, didn't have a lot of detail. So we were surprised by a lot of the things that we did see on Pluto. So this big white area, what is sometimes called the heart of Pluto, looks kind of like a heart if you zoom out. That's a bunch of nitrogen ice. We think there might be kind of a slushy ocean underneath this as well. If you look at some of the ridges that you're seeing on Pluto, those are water ice mountains. It has nitrogen snow. It has a thin atmosphere. It's a very interesting place. So I'm a big fan of Pluto, and I'm glad that we sent New Horizons out here a few years ago. But speaking of New Horizons, let me bring up all of our orbit lines again. Here we go. Show those. Bring back Pluto's orbit. And I'm going to show you where New Horizons did fly by Pluto. So I have a few more yellow lines I'm going to bring up in just a moment that show us how far our farthest spacecrafts have gone. So we visited the moon, the farthest that humans have traveled so far, just about 250,000 miles away from us, about 1.5 light seconds away. We visited Jupiter and Saturn, which are a few light hours away from us. And out here by Pluto, we're talking about a distance of about 10 hours or so. So if you were to travel from one side of Pluto's orbit to the other, that would take you about 10 hours. So I might have been off. I'm sure that Bing shared the actual numbers for Jupiter and Saturn, so probably less than what I was thinking to get to Jupiter and Saturn. But from Pluto, about 10 hours to get across this orbit here. And we are now to a point where we can see how far the farthest spacecraft that we have sent have gone. So these are the 5 farthest: Voyager 1 and 2, Pioneer 10 and 11, and New Horizons, which went out to Pluto just a few years ago. And these ones are going incredibly fast. These are some of the fastest spacecraft we've sent out, but also not only that, we've sent these out with the purpose of leaving the solar system behind. So when we sent these spacecraft out, it was with the idea that they would go in a direction that would take them out of the solar system entirely. But even so, even with these going incredibly fast, some of these have been going for a really long time. The Voyager missions have been going since the 70s. None of them have quite gotten as far as light could travel in a day at this point. So we're still only out to about a few light hours, maybe a light day or so at this point. Which brings us to kind of a tricky area out here in the universe, what I think of as kind of a strange gray area of sorts, where are we still in the solar system or are we outside of the solar system? It's kind of hard to say. It's a little hard to determine exactly where our solar system begins and where our solar system ends, because there's a lot of different factors there. Things like the planets and things that are going around the sun, but also the magnetic field of the sun, but also the gravitational influence of the sun. So there's a lot of different things that play into exactly where our solar system begins and ends. However, right around here, you may have noticed this little one over here starting to appear to move as we zoom away from our solar system. We're now starting to pass other stars that are in our galaxy. So once we get that far out, there's no question at all. We've definitely left our solar system behind. We're in interstellar space, the space in between stars. And our star, the sun, is starting to look like just one of these other stars out here. So before I was dimming down our sun a bit, it was not at its true brightness because we wanted to make sure to see the other things in our solar system easily. So now we've got the sun looking like its true brightness. And before I get too far away, let's check in with how far we've gone. So we weren't even quite out to a light day of distance. Even if we were traveling at the speed of light, it would take us at least a day to get to where the spacecraft we've sent out have gone. Now, if we wanted to travel from the sun to the closest star to us, Proxima Centauri, it would take us about 4 years. So space is a very, very large place. There's a lot of space in between things out here. And right around here is the last time that we'll be able to check in with anything we've sent out into space. So like we just saw, the farthest spacecraft we've sent out are still kind of near our solar system. So anything we're seeing from here on out is not because we've sent an object or a spacecraft or a camera out to that place to snap a picture. Anything that we're seeing from here on out is because light of that object has come to us. We saw it in a telescope, and then we were able to map it out or have a picture of it in that way. But there is one more thing that we have been sending out into space, and this is showing us where that is now, this blue grid here, which is called the radiosphere. So we're sending radio signals out into space all the time. The earliest radio signals that we made that were strong enough to escape our planet were sent out in the 1930s. So radio signals that have been strong enough to escape our planet have been leaving for about 90 years now. And so this grid, the radiosphere, is to show us how far those may have gone. So all of those radio signals, they're traveling at the speed of light. And out in space, if you don't run into something, you just keep going at the same exact speed that you started with. So those radio signals are going at the speed of light for many, many years. And like we saw, things are very spread out here. So the chances of crashing into something is very low. So the farthest that they could have gone is about 90 light years in any direction because they're traveling at the speed of light. So this is the edge of where anything that we've sent out into space has gone so far. But like I mentioned, that doesn't mean we can't learn about things outside of that. This is all still based on real data. This is things that we've seen when you look up at the sky, the closer stars. You can see the Milky Way, which we'll see from outside in just a second. And also we're learning about a lot of these stars that we're seeing too. These blue markers show us that there are stars that have exoplanets around them, planets outside of our solar system. Many of them have these. We've found over 4,000 exoplanets so far, finding more every year. And some of them are around stars nearby. But let's zoom out real quick because I do want to show us a model of our Milky Way galaxy. You can still see the radiosphere over there as we zoom away. It starts to look like just a teeny tiny dot as we get this far out into space. And out here, our model has shifted a little bit because before we were looking at a map of the nearby stars, many of which you can see if you just walk outside at night and do some stargazing. But now we're looking at a model that is based on different kinds of observations. So not so much just what you can walk out and just see easily looking up at the night sky, but more so looking at things in space in different wavelengths of light that our eyes can't see, looking at other places outside of our galaxy, combining all that together to give us an idea of what we think this galaxy would look like that we live in. So this is the Milky Way, the galaxy we're in. You can see really tiny right there. That's the radiosphere. That's how far our signals have gone because this thing is huge. If we were to travel across the Milky Way galaxy, from one side to the other, even if we were traveling at the speed of light, it would take us about 100,000 years. And earlier at the beginning of the show, I know somebody mentioned they wanted to see a black hole. No, I can't take us to a black hole right now. I don't have anything set up at the moment to do that. But right here, the center of the galaxy, it's very bright because there's a lot of stars that are more closely packed together at the center of the Milky Way galaxy. But if you could see past all those stars to the very, very, very center of our galaxy, that is where we would find a supermassive black hole. So there's a supermassive black hole at the very, very center of the Milky Way. And we just got to 5 o'clock, so I'm going to take us extremely fast out to the very edge of the known universe, because I always like to do that. I like to at least wave hi to the cosmic microwave background before we go home. So we're flying past a bunch of dots, which are showing us where there are other galaxies other than our own Milky Way galaxy. There's so many of them out here, and we are seeing kind of a weird shape of those galaxies because this is just what we've mapped out so far. That disk of the Milky Way lines up really nice with this. It's kind of blocking our view, making it so we can't see some of the galaxies that are out there. And hopefully, maybe soon we'll be able to map them out too. But real fast, I've taken us extremely quickly, much, much faster than the speed of light, to the edge of everything we can see. So to get across our galaxy would have taken us 100,000 years. If we were really going this far out into space, and if we were traveling at the speed of light, minimum would have taken us about 13 billion years. So we're really, really far out there now, back in time as well to the first light that we can see and document here on Earth. So I said back in time because if you remember, really early at the beginning of the show, I mentioned that if we looked at the sun, again, don't do that, never look at the sun. But if you were to look at the sun, that's how it looked 8.5 minutes ago. Well, in just a few seconds, I've taken us to what our universe would have been like over 13 billion years ago. So this is what it would look like in the past and not how it is now. Whew, but that's a long journey. I'm a little bit tired. So why don't we wrap things up, fly on back home. And as we fly on home, I want to encourage you again to check out OpenSpace. If you have a strong computer at home, to fly around well, often you need kind of a more robust computer. So if you have a nice computer at home, you can download OpenSpace and fly around through space yourself. If you walk outside tonight and it's a clear night, make sure to keep an eye out. See if you can spot Jupiter and Saturn, very bright and beautiful in the sky right now. And if you're somewhere really, really dark, maybe you could see our Milky Way too. So you can see parts of our galaxy, the Milky Way, if you're out somewhere extremely dark. So I always encourage people to do that too if you have a chance. But I don't want to leave you stranded out here. I always like to wrap up by flying back home. So we're going to fly past those spacecraft that we've sent out, the farthest spacecraft that we have sent out into the universe. And we're headed back, to the sun. Nope, I want to fly back to the Earth. Let's see. And we're going to fly back to the Earth, our lovely home out here in space, which is the only place where we have found life so far out there in the universe, and mainly where we've learned about a lot of the things that we just saw from our nice little blue dot, lovely, lovely planet here in space. So with that, I want to thank you all for joining me today for our tour of the universe. I hope you enjoyed flying around in space with me. And if I missed any questions, I apologize. We have a lot to get through in a very short amount of time, but I hope you enjoyed the places that we visited. And if you have a chance, if you're in San Francisco, be sure to visit us here at the California Academy of Sciences. You can see us in the dome and see this in real time, all surrounding you up on the screen. So it's really cool. Be sure to check that out. But with that, I want to thank you all for joining me today. I hope you're all staying safe, staying healthy, and I'll see you another time.